In 44 through 55, indicate which of the functions in the referenced exercise are one-to-one correspondences. For each function that is a one-to-one correspondence, find the inverse function. 45 is exercise 10b, and here I have exercise 10b. The function rule here is defined on this line. Define h from z to 2z by the rule h of n equals 2n for each integer n. Is h onto? Now, we don't need to do 10b. We just need to determine whether or not these functions are one-to-one correspondences, and if they are, then we need to find the inverse. Now, luckily for us, we don't actually have to prove that these functions are one-to-one in this problem. We just have to determine if they're one-to-one, and if they are, we can find their inverse. Now, let's remind ourselves that a function is one-to-one if all of the outputs of the function are unique. They're all different from each other. Now, this function takes every single integer and maps those integers to a corresponding even integer. So 1 goes to 2, 2 goes to 4, 3 goes to 6, 4 goes to 8. But all of those outputs are different even integers. So my hunch is that this function is one-to-one. But let's try to prove it. Even though we're not supposed to prove it, I think it's helpful to see why something is one-to-one deductively through a proof. So let's imagine here we have two different inputs that correspond to the same output. According to the function rule, the output of h of n1 is 2 times n1, and the output of h of n2 is 2 times n2. We could divide both sides by 2 to show that these inputs must therefore be the same. So if we have two outputs that are the same, then that must therefore mean that the corresponding inputs must also be the same. So this function is one-to-one. Now let's talk about how to find the inverse function. Now, if you've taken pre-calculus or maybe even algebra 2 and maybe calculus 1, then you've probably seen how to find an inverse function before. Usually what teachers do is they'll replace this function notation h of n with some letter, which I'll maybe call m equals 2n, where m represents the output variable, n represents the input variable. And then you swap the letters for some reason. I never understand that. I think that's actually a really problematic way of thinking about this, because then you're not only swapping two things for no reason, because I think that actually conceals the idea behind inverse functions. An inverse function is just another way of writing a relationship between two different variables. So for example, here we have m equals 2n, but another way of saying this is m over 2 equals n. Now, I wouldn't say that these two are different formulas. Even though they look a little bit different, they really represent the same information that's being conveyed here, that m is twice as large as n, or that n is half as large as m. Those are two different ways of essentially saying the same thing. So inverse functions essentially undo the operations in the original function. So if the original function here multiplies the input by 2, then the inverse function is going to undo that operation of multiplication by 2. So I would say h inverse, which by the way, this -1 is not actually an exponent. It's written in the exponent position, which is a little weird, but keep in mind that h is not even a variable in this context. H is a function name, and so h inverse is also a function name. So don't think of this as an exponent. It's not. Reciprocals are not the same thing as inverses, so just keep that in mind. But h inverse, now I'm not going to use the same letter n here because n comes from the domain, which is an integer. N is supposed to represent an integer. So I'm not going to put an n here because the inputs don't come from the integers. These inputs to the inverse function come from the codomain, which are the even integers. So I'll say h inverse of m is m over 2. This is how I would frame the function definition for the inverse here. So yes, the function is one-to-one, and here's the inverse function, m over 2. Now, actually, I think some math teachers, including myself, might take issue with how this is written. And that's because if you notice here, the output is a fraction. Now, keep in mind, m comes from the even integers. So if you take an even integer and divide it by 2, you also get an integer. However, this output is represented as a fraction, and there are no fractions in the integer world. And so for that, I think it might be conceptually more coherent to say m divided by 2 like this. That way, I think our outputs are represented in a better way. So I think both answers would be considered correct by most teachers, but conceptually, I think the second one makes more sense in this context. Thanks, everyone, and I'll see you in the next video.